Imagine training a powerful AI model, not with thousands, but with just 5 examples. This isn't science fiction. It's few-shot learning, a critical paradigm shifting how we approach machine intelligence. Traditional machine learning demands vast labeled datasets to generalize effectively, but in countless real-world scenarios, from rare disease diagnosis to novel material discovery, such data is simply non-existent. Few-shot learning tackles this scarcity head-on. It enables models to rapidly generalize from a handful of instances by leveraging prior knowledge, learned not about the specific task, but about how to learn. At its core, many few-shot methods employ meta-learning. Think of it as a model learning to initialize itself intelligently, or learning a robust metric space where similar objects naturally cluster, even with minimal exposure. Consider prototypical networks. They learn an embedding function that maps each input to a feature vector. Then, for a new task, they compute a prototype vector for each class, simply the mean of its few support examples in this learned space. Classification then becomes trivial. Assign a new query example to the class whose prototype it's closest to, in that very same learned metric space. This avoids traditional gradient descent on tiny, unstable datasets. Real-world impact: pharmaceutical companies can accelerate drug discovery, classifying novel compounds with limited known properties. Or, in industrial quality control, rapidly detecting new rare fault types with just a few visual examples. This fundamentally differs from transfer learning, which usually requires a fine-tuning dataset still far larger than a few shots. Few-shot learning truly pushes the boundary of minimal data dependency. A lesser-known implication is the challenge of bias propagation. When learning from such limited examples, any inherent biases within that tiny set can be amplified, demanding careful consideration of data provenance. Yet few-shot learning is increasingly integrated into large language models, enabling them to adapt to new tasks with just a few in-context examples, an exciting step towards more human-like adaptive AI. It reframes our understanding of intelligence, not just pattern recognition in abundance, but intelligent generalization from scarcity. This adaptability is the future of resilient democratized AI.